I will be heading back into Jupyter Lab for our data reclassification notebook. Okay, so in this notebook, we will be reading in some data and from our travel time matrix data that we created in the last, or that we used in the last notebook as well, and then applying some different classifiers to visualize the distances from the railway station in Helsinki, and then also applying our own custom classifier. So, for example, one could think that you are looking for an apartment and you have two criteria. The one is the travel time that it takes, and the other is the pricing, the rent of that apartment. So if both those two criteria are met, then you want to list that to go to view the apartment, and if either one of them is not true, then you do not want to go looking at that. So in this example, we don't have the rent and housing prices to work with, so we will be using the distance and time from our travel time matrix. So yes, but let's start with the classifiers that we will be using today. We will be using the PySal map classifier library that works in similar to many of the classifiers that you might have used in ArcGIS or QGIS. It has the same functionality. So we will be starting with using that. And before we do that, we can read about the different types of classifiers that are available. There are many different types in the PySal module. So we will be going through a few of those, showing examples, but just so you know, you can read more about the different classifiers in the documentation for PySal, for example. So yes, to begin with, we will read in our travel time matrix from our file that we have stored. So it's a GeoJSON file, so we can read that quite simply using GeoPandas read file, as we have done before. And as we're talking about accessibility, let's use a short variable name for that. So ACC for accessibility and gpd.read file. And we have our file path in the FP variable above. And let's read that, and then at the same time check out what we have in our geodata frame. So yes, this is familiar to what we had in the last notebook. We have here our data frame with the original grid cells with the different columns for the different types of transport and either distance or time measurements. So before we start plotting and mapping out our data, let's do some cleaning. So what in this example, we'll be using the public transport travel time during rush hour. So that is the column PT_R_TT. And then we will also be using the walking distance later on, which is stored in distance in meters. calculated using network distances. So in order to start cleaning our data, we will, as we saw in the last notebook, we had some values that were on -1. So that is NA values or no data values. So let's try to clean out those rows in our data set that has that. And then for our case, we will be using the public transport data. So if we then, one way we could do that is by selecting all the rows that have the values above -1 in that specific column. So let's try to do that. Let's replace our original data frame with our selection. So from the ACC geodata frame, let's locate all the rows that are either 0 or above. So that excludes all our no data values. So from that, we select, we locate from the accessibility data frame in the public transport column. I'll just copy the name here and paste it here. We select all the values in that column that are either above or equal to 0. All right, so if we run that, it should select all those rows and store that in our ACC variable. Okay, so let's have a look at that data and try to plot it. So we can use the acc.plot, and to define which column we want to plot, as they're here, if we just run it normally, it will plot the whole grid cell, but that doesn't tell us what we're interested in. We are interested in the one specific column of our data. So within our plot function or method here, let's say column, and again use the column from above here, the public transport in rush hour travel time. So if we plot that, then we will see it starts to change. There are some color variations, and we can see that they are darkest within the city center, close to the railway station, and lighter green out the further out we get. But what we can do with classifiers and the PySal package within Matplotlib is to choose a scheme that a classification scheme that we want to visualize our data with. So here, for example, we can try to take a look at the natural breaks classification scheme that tries to find natural breaking points within our data and group together based on that. So we can use the scheme keyword or parameter and pass it natural underscore breaks with capital N and capital B. And then we also want to pass it a K variable that defines the number of breaking points that we want to use. So we can, for example, pass that 9. If we try to plot that, we can see that the data changes. It breaks up even more. And we can also pass it a specific color map that we want to use with the CMap parameter. So CMap equals, and then if we take a look at the documentation from Matplotlib and the different color maps that we can use. Here is one. You can find a list of all the different and also a visualization of the different with their keyword or their name here. So let's go with red, yellow to blue color scheme or color map, which is called RD YLBU. If I can get back here. So RD yellow and blue. And then also let's get a legend pass that legend true will give us a legend in our plot as well. So if we run this, we now get a map in our desired color map, and that is classified in 9 different classes based on the natural breaks classification. Yes, so as you can see here, it takes the public transport column and rush hour and travel times. So naturally, it will be darkest really close to the central railway station, and then get darkest red there, and then get blue and darkest blue the further out, the more minutes it takes. Okay, so let's see. We can try to, in the interest of time, we can, if we copy this plot code, we can do the same plot, but change, for example, the column that we are interested in. So if we take a look at, instead of the public transport, we say the walking distance that we are, and try to plot that, we can get a map of that. And here we can see also the same pattern in one way, but here, for example, we might want to be interested in using an either different classification scheme or also different color map as we are looking at a different type of data than the travel time. Okay, so that is quickly how to classify the data and plot that. So now we will try take a look at a different method of classifying the data and getting of how we can better understand the underlying process that happens when we do classify our data. So here we are using the PySal map classify library. So let's first load that in. And now we can take a look at the different mapping or classifying schemes that we also saw above. So if we start to take a look at what the natural breaks classifier does to our data, we can dig deeper into that by using map classify and then dot the classification scheme that we want to look at. So natural breaks. And here, if we pass it the y parameter called, and then pass the column that we in our data that we want to look at or classify, then PT and R and TT, that was the public transport in rush hour, and the same amount of break points that we did above, we can see what is it exactly that this classifier does to our data. So here we get the similar to the legend above, we get the different classes that are broken into at the natural breaks levels, and also how many of the, here in our case, grid cells that are within each of those classes. So if we wanted to see how a different classification scheme would work on the same data set, we could, let's also copy here and paste it into this cell and remove the break points. But here take a look at what the quantiles classification scheme looks like on our data. We can see it then classifies our data into 5 different classes in a different way. Tries to find separating the data into 5 equal classes. So almost around 700 and something are all the classes. But one thing, an advantage of digging into the classifying method here that we're using is that we can also take a look at the different contents, and also use this to later on plot some histograms of our different classifying schemes. So first of all, we can take our classifier and access the different bins that our classifier has. Let's go back and use the natural breaks classifier again and store that in a classifier variable. So if we run that, it stores the classification of a natural breaks classification on our public transport column. And we can take a look at our classifier bins. If we do this, we can see we have an array of the different bins in our data set. So where the data breaks. Yes. So, and if we want to take our classifier and apply it to our data set, it's also possible to do that by making first a classifier and then applying it to our data frame in a sense. So let's try to do that and see how our results from that classification will end up. So in order to do that, we need to make a classifier. So let's store a classifier, replace that by a instance of the map classifier. Classifier. We'll keep using natural breaks here. And with the .make function, we can pass it how many breakpoints we want to have. So again, use 9 here. Run the cell to store that classifier in memory. And let's apply that classifier to our data frame. So let's make a classification. Classifications, let's store it as that. And then from our accessibility data frame, we will pass it a list of the columns that we want to use or want to apply the classifier to. So here it is our PT_R_TT travel time, and then apply a function as we've done before. So apply our classifier. And then check out what the classification then looks like. Okay. So running this cell here, we get the classification data frame here that has all the different has the index and all, and which classification bin it is assigned to. So remember, we made 9 different classes and breakpoints. So here, if we take away the head here, let's see if we can have an example of even more. We can see they are, each row in our data is assigned to one classifier or one class that our classifier made. And we can check out that what our classification is, what type of data that is, classifications. So we can see it's a data frame with our input column, the accessibility public transport data is classified into the 9 different classes based on the natural breaks classification. So what we can do is we can also store that data directly into our the data frame that we had above, directly into our accessibility data frame. So if we wanted to do that, we could do it by creating a new column in our accessibility data frame. So natural breaks, and then for the public transport, rush hour travel time. And then we could do if we copy here, the class applying of the classifier, we could then check out if we take the new or the accessibility data frame. Let's take the 2 columns that we are interested in. So this public transport column, and also our natural breaks column, and just to inspect that, do dot head. And here we can see the public transport travel time in minutes in the column to the left, and then which class it belongs to in the column to the right. Okay. I hope that makes sense. It's maybe a bit cumbersome to do it in this way, but it hopefully makes it easier to understand what is actually happening when we are classifying the data. So let's try to plot the new classified data that we have. So we can then take the accessibility data frame and then plot it using the column from the natural breaks classification. So NB, PT, RTT. And then also, yeah, let's try to just plot that and see what we get. So here we also get a map with the data that looks similar to what we did up here when using the natural breaks classification here. But something, if we try to plot a legend as well, we get a color bar from our legend. So this is one way to visualize the legend that we can do when we have, so in the natural breaks column, our data ranges from 0 to 8, as there are 9 classes. So then we can visualize it using a color scale bar instead of the different classes here as well. So that is one benefit of classifying our data and storing that in our geodata frame as well. And then the other another benefit is that we can also try to take a look at the plotting of histograms to better understand how the distribution of our classified data is. Yes, so if there are no questions at this point, feel free to ask or post in the chat if you have any. But I see only silence in the chat. So in that case, I will continue with into histograms. So histograms is a nice graphical representation of the distribution and the frequency in our data, and is closely related to classification. So let's try to make a few histogram plots for our travel time matrix. That is quite simple and built into pandas. So if we have a pandas data frame, so our accessibility data frame, and select the column that we want to plot, so our public transport, rush hour travel time. If we want to plot a histogram, we can use the plot function and then pass it the hist for histogram function. And if we run that, we get a super simple histogram of our data that is where it has grouped the data in different bins. So in this case, we can see that it is quite large groups that it has. So if we want to split that up into more granular view, we can pass it a bins keyword and pass it a, say 50 bins, and we get a better understanding of how the frequency of our data, how many grid cells are at the different minutes in our data set. Okay, so that is a very quick way to plot a histogram. But what we also could do is to visualize how our classifiers, how they split up our data in different breakpoints and see how much data are within each of those breakpoints in a way, or how large the width of our classes are. So to do that, we can again define a classifier. Here we will do it with the natural breaks classifier again. So we define a classifier using the map classify library, and using the natural breaks, as if I can type that correctly, breaks classifying scheme, and again using our as the Y keyword, passing our accessibility data frames public transport column, and using 9 bins or breakpoints as last time. So we define that classifier, and then we can, if we copy the histogram plotting from above, we will use that here as well. And then we will, if we just do that, we have a typo, different kind of breaks, and now I can't breaks. There we go. Okay, so here so far we have the same histogram, and then we can plot vertical lines in our histogram for each of the class breaks. So let's first see how we can plot a vertical line in our plot. So with the PLT for Matlab's plot functions, it will plot to the active plot. So that will be the same as the one that we just started using above. The plot library has a function called AX vline, so vertical line, where we can pass it a value. So if we pass it 20, we can, let's just run that to begin with. We get a line, a vertical line at the 20 values on the x-axis. If we pass it the color K for black, just to make it a bit more clear, we can see here we have a color. But what we then want to do is to create the lines for the classifier that we just created above. So as you remember, what we did earlier, we accessed the different bins in our classifier. So we could, for example, if we take our classifier .bins, we got an array of all the breakpoints that we have. So what we could do is take each of those values in a for loop and then plot a line to our histogram. So we'll take that, cut it, and create a for loop. So for a value, or we can say for breakpoint in our classifier bins, we will plot a line at the breakpoint with the color. So if we run this, then it plots one vertical line at each breakpoint in our classifier. And we can even prettify our plot by choosing a line style that is, for example, dashed. And then we can see we have a histogram that neatly plots out how our classification scheme works and which data is within each class. Yes. So that is basically how we do that. And we can, for the case of the example, we can do the same thing. I will copy this entire thing here and paste it here and use a different classifier scheme. So quantiles. And that gives a quick example of how different classifiers breaks up our data differently when we want to plot it. So that gives an example of how it's good to be mindful of which classifying scheme you are using when plotting your data. Okay, so so we have a check your understanding here, which we will do. So here I'm asking you to select a different column from the data that we have from our accessibility data and do a visualization of one of the classification schemes that we have from PySal and MapClassify, and then plot a histogram of the classification bins or make a classification or thematic map like we did up here using the same classification scheme. Yeah, so you can do that, and we will reconvene in, let's say, 6 or 7 minutes. Okay, so there's a majority of check marks. And yes, so this was meant just as a repetition for you on plotting and classifying. So I won't do the example myself, but I will continue on giving an example of creating a custom classifier that we can do and apply that to our data set as well. So in this example, we will be creating a custom classifier that takes one row of our data and then checks one column if that meets a threshold value, and then a second column checks if that meets a threshold value, and then outputs to a new column. So based on the example that I gave in the beginning of this notebook, so if you are at apartment hunting, and then you have two criteria, so that one is the distance or the time it takes to travel there by public transport, and the other one is either the price, but in our case the walking distance, or how far it is away from the railway station. Then if we checks if our row of data, our grid cell, meets those two criteria, then we will output to a third column to save that as a grid cell to check out when apartment hunting. So yeah, this example is we create a function here that is our custom classifier. So as I said, the arguments that it takes is a row. So it takes a row of data. Then we define which source column we want to associate with the first threshold value that has a upper threshold, and then a lower threshold value for the second column that we choose, and then the name of the output column that we want to use. So to use that classifier, and apply that function to our data, we first create the column of the suitable areas in our grid. And then to use that function or apply it, then the same as we did last week, one of the easiest way is to copy all the name of the function and all the parameters and arguments that we pass to it, so that we are sure we get all of them. So let's apply that to our accessibility data frame. So here, when we apply, the first argument is the name of the function that we want to apply. So that is custom classifier. And then row, as we're doing this on the first axis, which we will define in the end here. So if we just remember to have a comma and then axis equals 1 at the end, then we will drop the row here, and then we will continue to define all the different other parameters that we pass our classifier function. So yeah, I will make it easier to read, maybe, then I can have that on different lines. Yes, so for our first column, we wanted to check how that the travel time by public transport is lower than lower or equal to 20 minutes, as it says here above. So in our first source column, we will put the name of that column. So in as a string, we will put public transport, rush hour, travel time. And then the threshold for that column is in minutes. So that was 20 minutes as our upper threshold. And then for our second column, we define how far the walking distance is to that to the railway station. So here we have the walk underscore D for distance, and that threshold is that they are further away. Those grid cells are further away than 4,000 meters, so 4 kilometers, and we will store that output data in our suitable area column. Okay, and let's remember to store that in our accessibility data frame. And then we will also check out the head of our data after we run the apply function. So if we run this, I got a syntax error, 1 parentheses too many. So if we run that again, I have not run the cell above here with the function in. So we need to run that first to store it in memory. And if we do that and then try to apply it, then today was the day for many errors. We have a type error for axis. Let me try to get this back on one row. That was weird. Got multiple values for argument axis. Let me try to run that here. I don't know why that happened. Apply custom classifier. There's a comma between each. Yeah, let's just try to then. Okay, I see I might have the error here. So instead of renaming totally, then I could have. Okay, let me do this quickly then. So instead of replacing the src call equals 1, then I could have placed equals and then pt rtt, and the same for here. So walking distance and threshold 1 equals 20, threshold 2 was 4,000, and the output column was suitable area. So, all right, if we run that, then it is our custom classifier is applied to our data frame. We have a new column in the end called suitable area. So at this point, the first 5 rows are not suitable. They have been assigned the value 0. But let's try to inspect a bit more how many of the polygons or grid cells are actually was returned matches both of our criteria. So we can quickly check that out by using the selecting the column that we want. So suitable area, and then using the value counts function that will return the number of 0 values being 3,798. So, and for the number of polygons that were assigned the the one. So suitable were only 9 grid cells. So bad luck for our apartment hunting, but good to see that our classifier actually worked. So that is super. So we can try to plot that to see how that looks. So we will do our accessibility and plot that using the column that we're interested in. So the column would here be equals to suitable area. And then if we try to plot that, we could do a plt.type layout to see if that tries to automatically make things tighter and better. So here we can see the grid cells that are colored in yellow are our suitable area. So not that many, but from the city center, probably by public transport, the metro or something like that. And then, yeah, that gives us these few 9 grid cells that matches both criteria. And then if we wanted to, we could go into here into the thresholds and try to tweak the settings here to see how our results would then differ if we allow for more travel time or further distance and so on. So yeah, this is at least one example of how you can create a classifier for yourself and then apply that to the data set that you already have.